Yes, good morning everyone. So today is the fourth unit, that is nuclear power plant. So in this nuclear power plant we will go through history of nuclear power plant, nuclear fuel, nuclear fission, nuclear chain reaction, nuclear reactor, nuclear power plant in India, and conclusion. History of nuclear power plant. First nuclear power plant. Electricity was generated for the first time ever by a nuclear reactor on December 20, 1951 at the EBR-1 experimental station near Arco, Idaho in the United States. On June 27, 1954, the world's first nuclear power plant to generate electricity for a power grid started operations at Obninsk, USSR. The world's first commercial scale power station, Calder Hall in England, opened in October 17, 1956. Nuclear fuel. Nuclear fuel is any material that can be consumed to derive nuclear energy. The most common type of nuclear fuel is fissile elements that can be made to undergo nuclear fission chain reactions in a nuclear reactor. The most common nuclear fuels are 235U and 239Pu. Not all nuclear fuels are used in fission chain reactions. Nuclear fission. When a neutron strikes an atom of uranium, the uranium splits into two lighter atoms and releases heat energy simultaneously. Fission of heavy elements is an exothermic reaction which can release large amount of energy both as electromagnetic radiation and as kinetic energy of the fragments. Nuclear chain reaction. A chain reaction refers to a process in which neutrons released in fission produce an additional fusion in at last one further nucleus. This nucleus in turn produces neutrons and the process repeats. If the process is controlled, it is used for nuclear power, or if uncontrolled, it is used for nuclear weapons. Uranium 235 plus N is equal to fission plus 2 or 3N plus 200 MeV. If each neutron releases two or more neutrons, then the number of fissions doubles each generation. So this is the reactor, nuclear power plant, and reactor here it contains control rods, pressure vessel, water pump, core, water, steam, containment surface, turbine, electric generator, transmission lines, warm condenser water, cold condenser water, condenser, cooling water, water spray, warm moist air intake from a lake or river, etc. Components of a reactor. First one is control rods. Control rods made of a material that absorbs neutrons are inserted into the bundle using mechanism that can raise or lower the control rods. The control rods essentially contain neutron absorbers like boron, cadmium, or indium. Steam generators. Steam generators are heat exchangers used to convert water into steam from heat produced in a nuclear reactor core. Either ordinary water or heavy water is used as the coolant. Components of a reactor. Steam turbine. A steam turbine is a mechanical device that extracts thermal energy from pressurized steam and converts it into useful mechanical work. Various high performance alloys and superalloys have been used for steam generator tubing. Coolant pump. The coolant pump pressurizes the coolant to pressures of the order of 155 bar. The pressure of the coolant loop is maintained almost constant with the help of the pump and a pressurized unit. Components of a reactor: feed pump. Steam coming out from the turbine flows through the condensers for condensation and recalculated for the next cycle of operation. The feed pump circulated the condensed water in the working fluid loop. Condenser. Condenser is a device or unit which is used to condense vapor into liquid. The objective of the condenser are to reduce the turbine exhaust pressure to increase the efficiency and to recover high quality feed water in the form of condensate and feed back it to the steam generator without any further treatment. Next component of a reactor is cooling tower. Cooling towers are heat removal devices used to transfer process waste heat to the atmosphere. Water circulating through the condenser is taken to the cooling tower for cooling and reuse. Types of nuclear reactor. Reactors can be heterogeneous or homogeneous. A heterogeneous reactor has a large number of fuel rods with the coolant circulating around them and carrying away the heat released by nuclear fission. In a homogeneous reactor, the fuel and the moderator are mixed. Example of fissionable salt or uranium like uranium sulfate or nitrate dissolved in the moderator like H2O or D2O. Types are boiling water reactor, pressurized water reactor, pressurized heavy water reactor, high temperature gas cooled reactor, liquid metal fast breeder reactor, show turbine or generator plant common to all types. How a nuclear reactor works. 235 uranium fissions by absorbing neutron and producing 2 to 3 neutrons, which initiate on average one or more fission to make a controlled chain reaction. Normal water is used as a moderator to slow the neutrons since slow neutrons take longer to pass by a uranium nucleus and have more time to be absorbed. The protons in the hydrogen in the water have the same mass as the neutron and stop them by a billiard ball effect. The extra neutrons are taken up by protons to form deuterons. 235 uranium is enriched from its 0.7% in nature to about 3% to produce the reaction and is contained in rods in the water. Boron control rods are inserted to absorb neutrons when it is time to shut down the reactor. The hot water is boiled or sent through the heat exchanger to produce steam. The steam then powers the turbines. Nuclear power plant in India. Nuclear power is the fourth largest source of electricity in India after thermal, hydroelectric and renewable sources of electricity. As of 2017, India has 25 nuclear reactors in operation in 6 nuclear power plants generating 4,780 megawatt while 5 other plants are under construction and are expected to generate an additional 3.153 megawatt. India's nuclear power industry is undergoing rapid expansion with plans to increase nuclear power output to 64,000 megawatt by 2032. The country is involved in the development of nuclear fusion reactors through its participation in the ITER project and is a global leader in the development of thorium based fast breeder reactors. So, these are the nuclear power plants in India. So, this is the end of presentation.